Hello, in this video we're going to see how we should solve this integral, which is a little bit hard, but if you remember the way that we did integral from 0 to infinity, and that integral is very similar to that, the sine x over x dx, the approach is just the same thing. Just I want you to remind you that to remember the differential integral from 0 to infinity of sine of x squared dx, that is root pi over 8. Okay, so now what I'm gonna do, I'm gonna use the Feynman's technique of integration. Thus I would define the f of t to be the integral from 0 to infinity of sine of x squared t over x squared dx. Okay, so now if I find the f of 1 from 0 to infinity, I would actually find my integral that I'm looking for here. So if I differentiate this integral with respect to t, I'm going to be able to get rid of this x squared in the denominator. So if I take the derivative of both sides from 0 to infinity, the integral, the partial t of sine of x squared t over x squared dx, this is going to be the integral from 0 to infinity of cosine of x squared t over x squared times x squared dx. I just want to remind you that the integral from 0 to infinity of cosine of x squared dx also equals root pi over 8. Now, I can cancel out these two together, and I'm left with the integral from 0 to infinity of cosine of x squared t dx. Now, I can also write it as cosine of x root t squared dx, and you'll see why I did it for. Thus, the u, I'm going to define it to be x root t, and du is going to be dx root t if I differentiate both sides. And my u is going to be that, and I'm going to multiply and divide both sides by root t over root t, and it's going to be cosine of x root t squared dx. So this whole thing here is going to be collected as du. So it's going to be 0 to infinity of cosine of u squared over root t du, and it's going to be root 1 over root t, the integral from 0 to infinity of cosine of u squared du. Now, this integral we know has a value, exact value of root pi over 8. It's going to be root pi over 8. And now, this is going to be equal to f prime of t. If I integrate both sides now with respect to t, dt, my f of t is going to be, so this is t to the negative half, it's going to be t to the negative half plus 2 over 2 over negative half plus 2 over 2, which is 2t to the half. So 2t to the half root pi over 8 plus see some constant of integration, and if I take the limit as both sides as x approaches 0, I'm going to find the constant of integration to be 0. You can do it by yourself. So my f of t is going to be 2t to the half root pi over 8. Now, I want to find f of 1, so it's going to be 2 times 1 to the half root pi over 8, which is 2 root pi over 8. And if I move the 2 into the radical, it's going to be 4 pi over 8, which is root pi over 2, which is f of 1. Thus, the integral from 0 to infinity of sine x squared over x squared dx is root pi over 2, a very neat result. Thank you for watching this video. If you have any questions, please let me know in the comments, and I will read all of the comments of yours and I'll respond, and I'll see you next video.